Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of significant figures. What are sig figs? Well, when recording data, there has been an established convention of writing the measured data up until the first estimated value. Okay. Our equipment we're using, for whatever reason, doesn't have the degree of certainty we would like. So as a result, the last digit is an estimate and has some certain degree of uncertainty. Like that. So the greater the number of sig figs, the greater the precision. All right. Oops, sorry, didn't mean for that to happen. Those are going to be some of the examples we're going to look at here a little bit for the sig figs, probably on a different video. Anytime we record data, as a result, we're going to have to use the significant figure rules. And they arise due to usually limitations of the equipment that are given in our experiments. So we refer to these limitations as errors. And the errors are going to be the difference between the recorded measure and the actual value. So again, these are the conditions that can lead to such errors: the scale of the instruments or the uncontrolled conditions. Now, you can detect these errors by repeating your measurements and looking for something that might be out of the norm. All right. Mistakes, though, are going to be blunders that you made during the experiment or recording the data. Maybe you wrote down the wrong units or whatever the case may be in that scenario. Okay, so what are the actual rules for significant figures? Well, zeros to the right of a decimal point are always significant. So both these guys right here, guess what? They're significant. If the person measuring it took the effort to go all the way out to the thousandth place, then there's a reason. It's because their instrument allowed them to do so, and it was 2.500 on the dot. Okay, so all the trailing zeros are significant. Now, if we look at beginning zeros to the left of the first non-zero number, then all of these zeros are non-significant, and that's the zeros to the left of the first non-zero number there. Okay. So left, non-significant; right, significant. Now, if that decimal point is not there to the right, these are not considered to be significant. So at the end of a number without a decimal point. All the zeros found in scientific notation are considered to be significant. So here, this has 3 sig figs. This one had 2 because there was no decimal. This one has 1 because all of these zeros to the left of this non-zero number are significant. Okay? And then whenever you're doing operations, we have multiplication and division of numbers. You look for the smallest number of sig figs in the problem given. Okay, so this one has 3. This one also has 3 because of that trailing zero, and this one has 2. So because 2 is the smallest number of sig figs, your answer should only have 2 sig figs. And then in addition subtraction, you look at the numbers to the right of the decimal and you go with the fewest number of decimal places. Okay? So other than that, all non-zero numbers are significant, and you count those, and these are the rules for the zeros, and that's basically it. So learn these rules. If you practice a few of them, you'll never make a significant figure mistake again. All right? So I hope I've cleared up any confusion you might have. Practice, practice, practice. Thank you, and have a nice day.